Hello everyone and welcome back. Again, I'm just in the shop this morning just tidying up a few things here, loose ends on the little Peter Pan radio from the early to mid 1930s. When I left off, I had put this 5 watt 400 ohm resistor in again, so I showed the math on how to calculate the wattage or power requirements for this resistor. Again, just an example to follow if you're new into the hobby. Here's that 0.01 microfarad cap that I tacked in. It's the only one I had left in the box, and I have not dressed up the leads at this point in time. Again, that comes off the plate of the audio output tube, the 2A5 to ground, and it acts as a low pass filter, and again it suppresses the higher frequencies, and as you can see it sounds like it increases your bass. However, again, you're just pushing more of your higher frequencies above like 1100 hertz or so to ground. So the end result is the speaker itself, or what you hear, just has a little more bass effect. Anyway, you guys recall I just tacked in the AC lines, and there was a reason for that. You'll see laying here on the bench I've got a fuse holder and also have 2 safety caps. So I'm going to make a modification here to the circuit that's not on the schematic itself. Those 2 things. One again being the fuse holder, and the other being the 2 safety caps, not 1. And they'll actually be line to ground. So let me show you why and where I'm going to install those real quick. So here's the schematic itself. Again, this is your line input to this point. This symbol here represents the on-off switch, and then you can see your other line here is connected directly to the primary of the power transformer. So what I'll be doing is installing 2 0.01 microfarad safety caps, again from the both sides of the primary, one on the output side of the switch, the other directly feeding into the primary to ground as indicated here. So you may ask why 2? It's really overkill, but what I'm going to do, I'm going to leave this old receptacle here on the line cord, and you can see it's not a polarized line cord. So again, depending on how you plug this in, plus the accuracy of the wiring in the home, I think mine out here in the shop is spot on, but others may not be in the house. We can be assured that the radio itself, that the capacitor is connected across the line to ground, and that will provide again some safety protection, as well as filter out all that noise at those lower frequencies and kind of push it to the ground location as well. The fuse itself, again, just a common fuse holder. You'll see some 60 grit sandpaper here. Took time to rough this up on the back, and I also roughed up a spot here on the chassis. And I'm not going to drill a hole in the chassis. I'm going to tack on just a little bit of quick set epoxy and clamp that in place just for a few minutes, and then we'll get everything soldered up here. So the connection points real quick on the terminal strip here, just to show you guys, and we'll compare it to the schematic. One dead giveaway here where to connect the capacitor itself. You'll see my line cord comes in and it goes directly to the primary of the transformer. So if you guys recall, they've been following along, these locations here were the switch and the line cord input. Of course, you can see the line cord input. Well, if you look at this one real close here, this particular line cord input goes directly to the primary of the power transformer here. So I know one of my connection points will be from here to the chassis ground itself. Now what I'm going to do is just leverage the existing ground location here that attaches itself to the terminal strip. So I'll be soldering one of the safety caps from here back down to here, to the ground location here. And I'll do some DC resistance measurements here just to make sure that this connection itself against the chassis is suitable to use. Now you'll see the other is on the output side of the switch. So again, simply I can just go to the power transformer itself and look for that next primary winding that comes out that would head back to the switch. And that's actually located right here. And I know that's probably hard to see on camera because it's black wiring. But it comes to this terminal strip here, and it goes to this lead wire here. And then that switch itself, or the switch, is on the front side of the chassis, and it comes back to this location. So again, we'll be inserting the second 0.01 capacitor between this point and ground. And then again, regardless of how I plug this particular AC plug into the wall, I'll be protected. And again, we'll get some filtering out of that as well for, again, those frequencies or noise there on the low end. So let me go ahead and get the epoxy made up here, and just dab a little bit here on the back. I'll get this clamped. I won't bore you guys with that. We'll come back and I'll show you an update. And then once it sets up, we'll tack in some wires from here back over to the terminal strip, and I'll get these two safety caps in. One more quick update too. I had mentioned I wanted to play around with the volume control, and again, the volume control on this radio acts as a RF attenuator. And again, it's really just controls the bias itself, but you can see it located here is R1. And the what was installed in this radio was just north of 7,000 ohms, if I recall correctly. And let's see, 7.2, I believe I said. And the schematic itself called for 10K. So if you look at other TRF sets for the period, you'll see anywhere from 10K maybe to 15 to 20K potentiometers are used. So I went by my dad's, as I mentioned, and he had about 200 pots over there. So I went through and found more than I brought back 3 actually, but I tacked these in on a temporary basis. And I went as high as a 20K and down to a 10K. Really didn't notice any substantial difference in the performance of the radio other than where my max volume control would be before just that cutoff point where the tube was not happy on the bias. So what I'm going to do is just let everything be with the existing potentiometer there. Okay, I'm going to use very little epoxy just in case this needs to come off in the future. Just right here in this area. A little more up in here, and we're good to go. And let's go ahead and start getting these safety caps here tacked in real quick. A quick recap here on the schematic. The first one I'm going to take on right here will be the AC line coming in that attaches itself directly to the primary of the transformer here. So again, if we locate that particular one, it's going to be, here's my line cord coming in, and it's there's a black wire that loops back down here that runs back through here over to the transformer right here. So again, I'll just heat this area up here, and then I'll attach back down to here. Let's check the DC resistance real quick though between the chassis ground and my solder point location here, just to make sure it's suitable. Okay, looks like we're good. I was trying to just make sure I had a good connection point here. I'm going to take my alcohol real quick and just clean up this area before I apply solder. And then I'll probably take some of my sandpaper, or just take a file down in here. That's probably what I'll do, is just use a flat file and rough up this area just a bit, just to make sure I get a nice electrical connection. So I'll use my file first here, and I just kind of go over this and rough it up just a bit. It won't take much. And then I'll apply my solder on this side and run my leads through on the back side of both locations, and again solder over here on this location. Okay, let me continue to clean on this just a bit, and I'll get the alcohol out and wipe this off here, make sure we're good. Okay, that's funny, that's my last acid brush here. So you guys will get a kick out of that. I'll use this to clean this area up here. Add a little water here to my sponge here. And find my solder. Alright, we got that tinned. Let me just set that there for a minute. Alright, just looking at the orientation here, how I want the cap to reside. I think I'll have the value like such, and then I may try to fold this down like this so the value is facing up. And again, we're going to be going from this point here back to this point right here on the terminal strip. I'll probably have my hands in front of the camera. I'll try to get it at an angle here so you guys can see, but let me switch hands here. What I'm going to do, again, I just tack this connection here in. I'm going to see if I can just push this through. Okay, you can see I was able to push it through here and create a cold solder joint on a temporary basis. Now let me get the other lead here placed where I want it. Okay, I think that will serve us well. Let me go ahead and get some solder on here. Okay, that looks like that soldered up good. And then hit the other lead here. Alright, let me let that cool for a minute, then I'll cut off the extra lead lengths there, and then just check my solder connection. Get the alcohol here again and clean up when we're done with the second cap. Okay, there we have it. There's the first safety cap in. Alright, let's go back over here again. We'll look at the second one. So again, we just installed this one. Again, that's where the line cord again went directly into the primary of the transformer, is notated here. And you can see I've got a cap in, and it goes to ground. So the next one here will be on the output side of the switch. Again, it will come off the primary winding, and that location resides right here. So again, I'll be coming from this location, which goes back to the switch, is depicted here, to ground. Again, I'm going to use this connection point here. Alright, let's check the epoxy here and see how it's doing. Again, it's not cured because it'll take probably a good 24 hours, but it's safe to remove these small clamps. And now I can go and work in this area here safely and get some solder on. The other piece again I want to add again is the fuse protection. And again, sorry about the kind of the crude drawing here, but I'm going to put the fuse before the on-off switch just in case it fails. And again, you'll see them at times wired after the on-off switch. So in this case, what we're looking at, again, this was the primary off the transformer coming to here, and again this goes back to the switch, this line here that runs across the tube socket that I wasn't really pleased about. So what I'm going to do is actually remove the primary lead here itself from this terminal strip, because it's plenty long enough, you can see, and then I'll reroute it back over to the fuse itself, one side of the fuse holder, and then I'll tie in a new lead from this side of the fuse back to here. We'll do that, and at the same time I've kind of got this loosened up here. We'll solder in that second line to ground safety cap, and then we'll be wrapped up here. Well, of course we've got to get a fuse in, and then we'll play the radio again just to make sure everything's good. And one other thing too, I want to go back and show you guys some of the voltages that I calculated for the power transformer compared to the real results. Okay, after looking at this, I think it's going to be just as simple, and I've got enough lead length here from my transformer itself. I'm going to just cut this loose down here. As such. You can see this was my primary lead, and it's plenty long enough here to come back to this location. So let me prep this here and get it soldered into this connection point here, and then we'll run a new lead from this side of the fuse holder again back over here. Alright, let me clean this up just a bit better here, and then we'll get it tacked in here. Okay, I think that looks good. You can see the lead length here is perfect. I'll let this cool just a bit, and I'll just dress it up here in just a moment. Kind of push it back down in here. So again, that will be this lead right here coming from the transformer. Alright, I may have messed up. I'll show you how quick it is to make a mistake and realize how simple it is just to get things wrong compared to what you're trying to attempt versus what you draw out. So you can see what I did here is not the right approach if I want to place the fuse on the input side of the on-off switch. My connection point should be here. So let's reverse this and make it right. So I just wanted to point that out for folks that are new in the hobby. Double, triple check yourself and make certain that you're spot on. And again, I could go forward with what I'm doing. It would just put the fuse on the output side of the on-off switch, and you'll see radios or other pieces of equipment done just in that fashion. So let me unsolder this lead, and then I'll probably end up pulling back out my other lead here as well that I had tacked in. It goes back here, and just clean up my AC line cord input. I think this cord's rather long, so I'll be able to strip it back. And then what we'll be doing is taking one side of the AC line input here and attaching it back to this location. Then we'll take this transformer lead and get it attached back over here and put the safety cap in. So let me just cut this out or unsolder it real quick. Okay, and again, this is the lead here. that will run back over to the fuse itself. Alright, let's clean this up here. Okay, as I was kind of cutting off this outer coating here with my cutters as such, I accidentally got into the wire right here. Not to damage the wire itself, but just the shielding, so that may not be showing up, but I just spotted that. I'll put a piece of heat shrink over this area, but it'll be fine. This one looks good. I'll check how this thing is wired too. You'll notice there's looks like a black tracer here on this lead, so theoretically this would be attached back to the hot lead, I believe. We'll check that. There we go. Okay, I'm going to just simply tie a knot in the line cord here to act as a strain relief. That's the way it was done before, so nothing fancy there. Okay, let me look at the other end of this line cord here. Yeah, just looking at this, you can see both connection points are black. And again, if I decide to change this out later for one of the knockoffs that look just like this, is polarized, I'll do so. Another thing that you can do is clip these back just a bit, make one side larger than the other if you're concerned about the polarization. I probably won't play this radio much in the beginning, so I don't think I'm going to worry myself about the polarized plug at this point in time. However, I think I will go ahead and take this one that has the black tracer right here that's probably not showing up well, and go ahead and attach it here to the fuse. Let me get the transformer lead back off. Okay, I think that's looks good the way it's laying in there. Let's refer back to the schematic real quick before I solder this up. So let's go back and review where I'm at right now. You can see what I'm doing is taking a fuse indicated here, and I'm inserting the line cord input into one side of the fuse holder. The other side again will run back over and tie in to this terminal strip again, which is the on-off switch. So let me get this soldered up, and then we'll run a lead from this side of the fuse back over to the terminal strip itself. Okay, that looks good. Let me get a piece of black lead wire here, and again we'll tie in from here back to here. Alright, let's tin this wire here. And what I'm going to do for now is just estimate the length of wire that I need. Then I'll clean off the extra here. Again, being mindful not to be too wasteful. Let's see, I think I'll go ahead and throw it down through here and get the wire routing itself done the way I want it. Okay, here we have it. I'm going to go ahead and heat this back up I think I can just heat this up and then we'll form it, then I'll resolder the connection here. Okay, I'll let that sit there just for a minute and then I'll clean this up. Okay, that looks good. Okay, that looks good. Let me get this soldered up here. Alright, sorry about that, guys. I'm going to have the soldering iron here in your face. So again, here's where I'm at right now. Again, you can see my line cord input would be represented here. I'm going through the fuse. We're looping back over out of the fuse back to the on-off switch as such with this lead that I just tied in. So let's get the other connection point made where I desoldered it and get the transformer tied back in, and we'll be done. Okay, I had my head here in front of the camera, so just want to make sure I got down in here again. That's where I had to rebuild that terminal strip. Just using some hookup wire. I wanted to make sure electrically that I got a good connection there, so it should be good to go. So I've got another loop location there I can use. Let me get the other safety cap put in, which will be, again, this one. Will be coming off, again, that connection point right here from the on-off switch. This location back to ground right here. Let me clean these leads up now. Alright, let me get the alcohol out right here and just clean up everything. Okay, I think I'm pleased with that. Let me just put my magnifiers on and just double check my solder connections here. Make sure I don't see anything that needs to be touched up. Alright, let's get the VOM here. We'll go to the continuity setting, and what we'll do, I'll just pick a location here on the AC plug, and I'm going to check here for continuity. Nothing there. Okay, we've got continuity there. So what I'm going to do, even though this is not a polarized plug at this time, I'm going to take my marker here, permanent marker, and just put some black on it. Okay, let me test it here one more time. Alright, great. Alright, let me go grab a 1/2 amp fuse. Again, this radio draws about 0.37 amps of current. I'll put a fast flow 1/2 amp in. I think that's what I've got handy, hopefully. And we'll check the DC resistance here across these 2 points. And before, I think when I was doing the testing on the transformer, I read just under 14 ohms of DC resistance. So let's check real quick, flip the switch on and off, and just make certain that we match, close to this reading today. Let me grab that fuse real quick. Time to reorder some more. You can see here I've got 2 left and 1 now. Alright, let's check now and see what we've got. Again, we got the meter set there to DC resistance, and I'm looking close to 14 ohms. So right now that's a good sign. Flip this on. And 14.5, 14.4. So very good. Alright, let me turn this thing over and just make sure I got all the debris out from underneath the chassis itself. And let's fire this thing back up again and make sure it still plays. Okay, something else I wanted to share real quick that I mentioned just a bit ago were my voltages. Again, for those that followed along, when I tested the power transformer, I used my audio signal generator as a source in lieu of using a variac. So you can see that I've got my calculated voltages here. So if you look at the high voltage winding, I was at 343 and 347. And when I tested the power transformer with the Type 80 tube out of the socket, you can see I was at 339 and 343, so extremely close to what I calculated. The filament pin for the Type 80 was 594, and again that was with the Type 80 tube out, and you can see the heater voltage on the 2A5 was 253, and what I was estimating or calculating the voltage to be was 5.9, I believe, or 6 volts on the filament for the Type 80, and the heaters I think came in at 3 volts. So again, that was with no load. So you can see using the audio signal generator was a proven reliable method for calculating what the voltage would be. Okay, I just wanted to point that out, and again you can see some of my measured voltages here as well at the plates, and just to make certain I was not exceeding the maximum voltage for the tubes, being that I think this power transformer had been replaced at some point in time. Anyway, I'll freeze the screen here just for a minute, and if you guys can read that, you'll see my notes here for anybody that needs this for future reference. Thanks again for watching.